So our topic in chapter 3 is exponential functions. But first, let us know the objectives in this lesson. First, it represents an exponential function through its table of values, graph, and equation. Second, we will learn how to find domain and range of an exponential function. Third, we will learn how to find the intercepts, zeros, and asymptote of an exponential function. And last, we will learn how to graph exponential function. And now, let us talk about what is exponential function. An exponential function is defined as a function with a positive constant other than 1 raised to a variable exponent. A function is evaluated by solving at a specific input value. Continuous growth or decay models are exponential models that use e as the base. Exponential function are functions where f of x is equals to b raised to x, where b is greater than 0 but not equal to 1, and x is any real number. In the equation f of x is equals to b raised to x, b is a constant called the base and x is an independent variable called the exponent. For example, f of x is equals to 5 raised to x. Our base here is 5. Next, f of x is equal to 7 raised to x. Our base here is 7. F of x is equals to 4 raised to x. Our base here is 4. F of x is equals to 9 raised to x. Our base here is 9. In this part, we will identify if it is exponential function. Number 1. F of x is equals to x raised to 2. Is this an exponential function? No, this is not exponential function because the base must be real number. Second, f of x is equals to 1 raised to x. Is this an exponential function? No, this is also not exponential function. Why? Because the base can be any real number but not equal or less than 1. Third, f of x is equals to x raised to x. Is this an exponential function? No, this is not an exponential function because in this example, the base and the exponent is both variable, which is absolutely wrong. And now, let us move forward to the properties of the exponential function and their graph. Number 1. The domain is a set of real numbers. Number 2. The range is a set of positive real numbers. Number 3. If b is greater than 1, f is an increasing exponential function. If b is greater than 0 but less than 1, f is a decreasing exponential function. Number 4. The function passes through the point 0 and 1 because f of 0 is equals to b raised to 0 is equals to 1. Number 5. The graph approaches but does not reach the x-axis. The x-axis is the horizontal asymptote. For example, y is equals to 2 raised to x plus 3. So, here is the solution of our given example. Y is equals to 2 raised to x plus 3. But first, let us solve what is our exponent. So we will solve x plus 3 is equals to 0. We will transpose the 3. We will become x is equals to negative 3. And now let us solve the y. Y is equals to 2 raised to negative 3 plus 3. It will become 2 raised to 0 is equals to 1. And now, let us solve the next number. Y is equals to 2 raised to negative 2 plus 3 is equals to 2 raised to 1. is equals to 2. And our other y is 2. Next, y is equals to negative 1 plus 3 is equals to 2 raised to 2 is equals to 4. Our third y is 4. Next, y is equals to 2 raised to 0 plus 3 is equals to 2 raised to 3 is equals to 8. Our fourth y is 8. So next, y is equals to 2 raised to negative 4 plus 3. It will become 2 raised to negative 1 is equals to 1 over 2 raised to 1 is equals to 1 half. So our fifth y is 1 half. So next, y is equals to 2 raised to negative 5 plus 3. It will become 2 raised to negative 2 is equals to 1 over 2 raised to 2 is equals to 1/4. So our last y is 1/4. And now let us graph it. Reflections in the coordinate axis. Reflections in the coordinate axis of the graph y is equals to f of x are represented as follows. Reflection in the x-axis, f of x is equals to negative f of x. Reflection in the y-axis, f of x is equals to f of negative x. Use equation 1 to describe the transformation that yields the graph of equation 2. Equation 1, y is equals to 3 raised to x. Equation 2, y is equals to 3 raised to x plus 1. The graph of y is equals to 3 raised to x plus 1 shifts the graph of y is equals to 3 raised to x 1 unit to the left. Next, y is equals to 5 raised to x. Equation 2, y is equals to 5 raised to x plus 3. The graph of y is equals to 5 raised to x plus 3 shifts the graph of y is equals to 5 raised to x 3 units upward. And that's all. Thank you for listening. May we have fun and productive learning seasons ahead. Welcome to General Mathematics.